primera cosa, scusami, ma il mio spagnolo è inesistente. So, I promise to you to speak in a very, very slow English with a very thick Italian accent that is very similar to the Spanish, but because when Jose Maria asked me to give this talk, I thought to students, please, it's for students, not for the primera fila. So, anytime that you do not understand, stop me and pregúntame. Okay. The second point is that if you want to, at the end, make me any question, please do it in any language you know, that I will be able to more or less to answer. Let me say again thank you to Jose Maria, who presented me as the numero uno, but I don't think to be the numero uno. And let me add only that I am here thanks to Laura Sanna. Laura Sanna is now working with Jose Maria since 1 year and something. And she has been a student in my university, and now she's one of the best friends I have, so I kindly appreciate her invitation here. So, let me start. Okay, I guess that everybody knows why now we are talking about paleoclimate. At the end of this talk, you will see why, but paleoclimate is become one of the most important items to try to discover or to understand where we are going on. If you open any kind of newspaper, you find that we are cooling, we are warming, we are changing our Earth, and probably in the next 20,000 years, we will disappear somewhere. Now, as geologists, we are trying to understand if this is true or not true, and how fast we are going toward these changes, and of course, how humanity, so el pueblo puede acelerar o decelerar esta cosa. Okay, I have written here some items. Climate, of course, is changing. Which are the evidences of this changing? And is this a normal process or is something that is strange, that is occurring now but it never occurred before? Which, this point important, which have been recent past climate changes? Because of course, I guess that more or less all of you have done a course of geology. When you speak about the story of the Earth, you speak about millions of years or billions. The age of the Earth is 4.5 billions. And our normal life is 80 years. So we cannot compare our life in a biological sense with the story of the Earth. The scale doesn't fit. Okay? So it's important to understand what has occurred in the past to try to understand a possibility of the future. Of course, which is the impact of this climate change? I am studying beaches. And of course, if one beach goes under erosion, we lose economical power. Because if you think that most of the people come to Italy for the sea, if we lose beaches, we lose economic income. So for these beaches are important. Nobody cares about the desert, because very few people go to the desert. So our aim is to try to understand how much money we have to invest to prevent our beaches, to maintain them economically active. Of course, at the end, I would like to say something, because otherwise there is no reason to be here. Okay. Il percorso in Italian, pathway in English, is actually, first of all, we have to understand how the climate is changing normally. Second, which has been the causes of climate change in the past. And of course, because I am a geologist, I would like to show you few evidences in the rocks about this changing. And of course, at the end, there will be something again. Okay, first of all, I would like to students, of course, to underline that the Earth is rounding around the Sun, correct? No trouble? And we know that this circuit is not a ring, but is an elliptic. And this stuff is not a fixed elliptic circuit, but it changed through time. Second point is that the Earth rotates around its axis, but this axis is a little bit tilted. And if you have heard about the earthquake in Japan, you have heard that the axis tilted a little bit more than normal. We will talk about this. The other point is that you know that in the summer, our hemisphere is tilted in this side, and we get much more radiation from the sun in a direct way. Okay? These are the important points. Let me go further. The other point of climate is that climate is changing. Thinking about latitude, of course. So if you think to Canada, the climate in Canada is totally different from the climate in Almería, and the climate in Sardinia is pretty similar. And of course, in the other side, we have the same changes. And this latitude and longitude, if you want, but latitude, are not fixed through time. They change, and we will see how. And of course, if you go up, I do not remember the highest mountain in Spain, but it's in the Canary Island, and it is covered by snow more or less any time of the year, because they're high. Okay? Now, few people instead know about the conveyor belt. Probably most of the people here, they know about the Gulf Stream. And you know that thanks to the Gulf Stream, population in islands like United Kingdom or other islands close by can survive, although they are in a very high latitude position. Okay? Now, this conveyor belt has a double temperature. You can see a red and a blue current. And these two currents, one is warmer and one is colder, round around the oceans, and they take 500 years to reach one point during their path. And 500 years are something like 7 generations of people. So it takes 5 or 6 or 7, if you want, generation of people to this point from here to come up to here. What does it mean? Does it mean that if I make a small change around here, the effect of this change will be received here 500 years later? Example. You have heard that in this part of the ocean, around here, there is a big island of garbage. La basura. Okay? And actually we are studying which is the behavior of this basura in the middle of the ocean to control or to change, if you want, this current. Because of course, not me and you, but probably the sun of our sun will get an influence of a small change. And of course, think that if we cool this red line, ice can come down and can generate different behavior in the climate over there. Clear? Okay? Now we start a little bit to think which are the climate changes that we know. First of all, I am a geologist, and of course, I deal with plate tectonics. Do you know plate tectonics? Do you know that every something like 500 millions or 300 millions of years, all the continents link together to form a supercontinent that the last one was called Pangea, or Pangea if you want the English pronunciation. And of course, during this time, forget about the conveyor belt. The conveyor belt did not exist, of course. So the climate here was dramatically different from the climate we have now here. And if you go on the field, I don't know here in Spain, but There are several, I have seen on the road coming from Barcelona, several spots, you can find the Permian rocks. And all the Permian rocks around the Earth are red because the climate during that time was arid. Okay? Now, just to give you an example, here you can see the evolution of arid in this color zone through time due to plate tectonics. But of course, this changing takes millions of years, so they are out of our mind. Let me go a little bit close to our mind. So here you can see that there are cycles, thousands of years, just a little bit close to our mind. And which is the trigger for this cycle? Is the position of the Earth around the Sun. You can see that these circuits change his path every 100,000 years. And what this implies? This implies that the Earth could be a little bit farther or a bit closer to the Sun. And when it's closer, you get much more Sun influence on the Earth. And when it's farther, the contrary. Okay? The other point, the axis. The axis, remember that now we are 23.27, just a little bit more now means today due to the earthquake. So what does it mean? That we are close to the maximum tilting of the axis. And of course, this tilting takes around 40,000 years to flip back and forth. And during this flip back and forth, of course, the sun radiation changes. Last point is, you know that the Earth turns around, and of course, because the axis is not vertical but is tilted, it makes a kind of, in English is a wall, but doesn't matter, is analytical. And this stuff is bigger or smaller, and this change occurred in 21,000 years. So we know that there is a sun radiation changes through time due to the position of the Earth around the sun. But still, thousands of years. Now let me go closer. Sunspot. Do you know about sunspots? Okay, I do not know a lot about sunspots. But what I know is that into the sun we have a magnetic event that causes the presence of sunspots on the sun surface. Now if you look, this one is 2009, we have no sunspots. And this one was 2000, there were several sunspots. Now, what we have seen looking at the rings of the trees, you know that every year, one tree makes a new ring when it grows. We have seen that in Wolf, Sporer, Maunder, Dalton. So around this period, we have a period of solar weakness. We will see later what was the meaning of this stuff. And we have seen that more or less there is a cyclicity of 500 years in large scale, up to 10 years. And finally 10 years is something that we can touch. Okay? 500 years is a little bit much. Now, if we talk about temperature of the Earth, you have always to take in your mind that the Earth is cooling, the venta fria. Okay? If you look in the Paleozoic, the temperature to now, a decrease of several degrees of the temperature. Okay? And of course, for several reasons. And we went, if you go to in recent time, we wanted to explore how detailed could be this curve coming closer to our time. So what we did, we went to Antarctica, and you will see later, and we dig a well in the ice, and we reached the boundary between, actually we arrived in the middle of the Miocene, not too bad, so only 20 millions of years ago, and we started to reconstruct a curve. And after we detailed this curve, and recently, we, not me of course, not only me, Okay, we did several wells in Antarctica and in Greenland. And you know, of course, why? Because Antarctica and Greenland are the two most arid countries in the Earth. What does it mean? That anytime you have a rain, of course, this became ice, of course, snow, and this can be preserved in a well through time. So if you drill 3,000 meters, you drill millions of years, okay? And through this stuff, we took a nice ice cube, actually ice tube, and we went in a lab and we did this complicated stuff that I have summarized here. So we have seen that in the last 700,000 years, we had 8 glacial stages and of course other 8 interglacial stages. We understood that interglacial stages were as much warm as today. Okay? We knew that the human effect on climate is mainly related to CO2. CO2 in the atmosphere due to the use of hydrocarbons in the last, in the last 200 years, so from the Industrial Revolution to now, has increased from this point to that point. So, like the amount of CO2 released in the atmosphere from the Earth, from normal processes, in 200,000. So we did in 200 years what the Earth normally does in 200,000. And this one is extremely important because we can touch this time here, okay? But from the study of the ice core, we did this nice stuff that is strongly debated, but what is important to show you is that we recognize actually 8 glacial and 8 interglacial. Actually, there are only 4 here, to simplify, where we can speak about the last 3,000 years. 4 interglacial and 4 glacial times. What we did to recognize these glacial interglacial times? We sampled the ice and we measured the concentration of oxygen and carbon, and we did a kind of comparison between the past and the recent amount of this stuff. And we recognize a little bit this stuff here. And I would like to underline you that we are living in an interglacial time. Before there was a glacial time, and before again there was another interglacial time. Normally, to simplify, we use even and odds number, and even are interglacial and odds are glacial. Okay? Now, just to give you another datum, if you look here, a glacial period can last for around 60,000 years, and an interglacial normally is a little bit shorter, around 50 to 45,000 years. Okay? And if we detail a little bit, you can see that here is very smooth and very regular. If we detail a little bit, you can see that the climate curve is not something linear, but is going up and down several times. And just to give you an idea, this point here is the end of the last glacial time, and this point here is the beginning of this interglacial time. And from year to year, it took few thousand years, something like 6,000 years, and during this time, the sea level increased of about 130 meters. But if we look here, and from this point here, we enter in more or less in the modern man story. So from this point here, we started to have influence in the climate about humanity. And I would like to underline you that There were several up and down, and of course, going close and close to present time, we can detail, of course, and of course we can recognize more and more up and down. Just to give you an idea, we know exactly that there was a warm Roman period, a Minoan warm period, a medieval warm period, and the Little Ice Age. If you go to Belgium on holiday and you go in a museum, you can find several painters painting Belgium during this century, so during the 17th, during the 18th century, with the Belgium covered by ice. Okay? Now if you go to Belgium, it's not covered by ice. Now, of course, during those times, Hannibal crossed the Alps and wanted to conquest the Roman Empire, but fortunately for us, he felt stuck. But to give you a little bit of background, to zoom a little bit in the last 1,000 years, to show you that there was a warmer period, 2 degrees more or less above the present temperature, and there was a little ice age with 2 degrees below the present temperature. And during this time, the Vikings, for instance, they were actually, they are, because Danish are Vikings too, they were as super sailors, and they went to Greenland. And the name of Greenland means Terra Verde. It's not green at all now. And the Northwest Passage that now is opening again was used by the Viking to pass and to go to North America. And of course, the vice versa, during the Little Ice Age in the 18th centuries, what there was the covering of Greenland by ice. This passage, of course, closed, and we had small little changes, like an increase in amount of ice in the Alps or in other similar chains in the world. Now, just to give you an example, we are now trying to understand the solar cycle variations, and we have seen that every 10 years we have a peak, a maximum peak, and of course a minimum peak. And we have seen that we are sensible to these variations. Okay? So now you have a kind of background to understand the next step of my talk. Of course, when I work, I am a sedimentologist, and sedimentologists want to reconstruct the Paleo environment. So which walls, and how develop the past environments. And I use stratigraphy, you know, the stratigraphy to place one stratum over another to understand which is the older and the recent. I use, of course, geomorphology to understand the processes, especially erosional process, geochronology to understand the time of this event, and of course geochemistry, because I show you that to make climate correlation we use isotope of the oxygen and of the carbon. Now, of course, we have worked in Antarctica and in Greenland. I am mainly working in Canada, and now I am working in Sardinia and in the Alps, but mainly in Sardinia. So I will present you some evidences in Sardinia. You know what is Sardinia? I want to hear see. Okay? Okay, I would like to show you a couple of examples. One example of a situation here, so facing Spain, and another situation here facing Italy mainland. Okay? Forget about the names, but just to give you an idea, this promontory here is made of Jurassic to Cretaceous limestone, developed during the Pangea time and stuff like that. Of course, because it's a limestone, we have several karsts and several caves. Most of them now are submerged, but few of them are half and half, partially and partially. And what is interesting is that in this half and half, it's possible to see a kind of a line here, more or less at 4 meters above el presente nivel del mar. Okay? Okay? And we have dated this point to 125 kilo years. Remember this point. I will use it again. Now, there are some other caves in which we have found Neolithic barrier, and of course, I do not think that the Neolithic guys were so stupid to bury the dead guys under the water using a snorkeler or something like that, because they are 7 meters below the sea level. And again, we have another cave here where we have found spectacular remains of cervo sardo. Cervo sardo is a deer that extinguished more or less between 40 to 30 kilo years. And of course, the deer fell into the cave, and now, because it is totally concretionate, so covered by speleothems, means that the cave was above the sea level to include these bones. Okay? Now, the simple history that we can reconstruct is that these caves were in one time flooded, and after they were emerged, and of course during this time the poor deer walking around here fell down, and now it's part of speleothems. But if we want to enter much more in detail, we have to compare something that for us is much easy to understand. Now here, where there is the umbrella, you can see the modern beach, not too bad to work here, believe me. And here, now you have to believe me, here this one is an ancient beach. But if you look carefully, you can see the prograding shape of this one. Here I have put a drone. So you can see that this one is the fossil equivalent of the modern beach. But this fossil equivalent is some meter below of the sea level. Now, these two guys here are not basketball players, but they could be around 1.5 meters, Laura. So anyway, but you can see that there is a little bit more about them, and here about. And now you have to trust me, this point here is exactly the equivalent of this point here. It's what we call battigia in Italian, and in English it's nice, the name is sand run. Because if you go to the modern beach, you can see the sand moving on the beach. So it's a sand run. Okay? And you can see that from here to here, there probably could be more than 3 meters. Now, if we go in another place, here, can you see this stuff here? This stuff here, it's now called lithophyllum. Litho from lithos, roca, and phyllum, planta. So it's something that now is living in intertidal zone. So between the baja e la alta marea, che non sabe come si dice in Spagna. Okay? And let me go further a little bit. Here you can see that below, above this number 2, there is a reddish stuff, probably pyrosol, and after there is a number 3 that is wonderfully exposed here. So, what is this number 3? This number 3 are dunes. What bloody hell does dune there? Come on, dune? Dune now in Sardinia are present only in 3 places all around Sardinia. One is a national park, and another one is a wonderful beach in the north. But here, you can see that from the base to the top, there are something like 12 to 13 meters. So to preserve a so high dune, it means that there were several. So what we have done here, we have done OSL ages. I have no idea, but I guess that you have no idea about OSL. O means optical, S stimulating, L luminescence. So we use quartz grain to date the rocks. Nice, eh? And how we do? If this one is a quartz grain, when this grain is under the sunlight, it loses any kind of natural charge derived from gamma ray or from gamma ray, what is that? Uranium, thorium, natural radioactive materials present in the Earth, because the sunlight is so strong, and this became zero, the other radiation. So if I cover this quartz grain with other sediments, this grain can be recharged by the natural radioactivity present in the Earth. And if I know the amount per day of this recharging, and I can measure the total charge, I can get the time of burial of this deposit. Okay? This is what I am doing in my lab, together with another university in Milano and with Denmark. So, the other story, but the important stuff is that I got 1, 2, 3, 4 actually ages. And I were able to see that, for instance, the dew formed during 47 and 77 kilo years, so 1,000 years ago. Important, you will see later. Moreover, we have found tropical warm fauna in the beaches. And looking in detail, we have found, can you see here, the clinoform related to dunes, similar to the big one I have shown you before, and here. Have you never heard in your life tidal notch? In Italian we call it solco di battente. No idea about this expression. But here, look here, this one is the modern one. So it forms when the waves cut and arrive at a carbonate cliff, and they excavate a little bit the carbonate bottom, and they form this kind of scour here. And here we have this scour that is 2 meters above the present sea level, and here we have another small one 4 meters above the modern sea level. Okay? And of course the dunes here are covering everything.